right. Just recording it so that I can put it on the blackboard.
I'm just not going to say anything.
No, just forget it's even on. Okay, so these branches here are in the first and the third quadrant, right? So, first and third quadrant. Someone asked me, do I have to write it in Roman numerals? No, you don't have to. These are your notes. Oh, by the way, starting tomorrow, the new stamp sheet I have has a stamp for taking notes and a stamp for doing the homework. So if you are taking notes, if you are a person that can't take notes while I'm doing this, then you're going to have to go home and fill them in when you get home. Okay, if you want credit for the notes. The notes class counts as classwork, the homework counts as homework. Okay, so these, let's talk about the asymptotes first. These graphs, as you see, this one comes up, but it doesn't quite touch 0. So this is our horizontal asymptote. And where is our vertical one, guys?
A y-axis.
Yeah, on the y-axis, right? And like that other one is dotted too. Okay, and this is our vertical asymptote. Okay? In other words, these graphs don't quite ever get to y equals 0 or x equals 0. So our vertical one is going to be at x equals 0, and the horizontal is going to be at y equals 0. So will I have any x-intercepts?
No.
No, it'll never cross the x-axis. And will I have any y-intercepts?
No.
No. Okay. So let's talk to, these are actually, I think, easier domain and range questions because we're only talking about what it can't be, really, in this. So what's the domain? Where can it be and not be in this? The asymptotes. Good. Okay, so this is going to be such that x is what? Not equal to 0, right? So the graph comes up to 0, but it just doesn't quite get there. Do you see that? And then, of course, so what's the range?
That's like that y can't equal 0.
Good. Y such that y is not equal to 0. Get it?
Yeah.
So actually, domain and range are kind of easy on these, right?
So will it always be like that?
It will always be like that with the asymptotes. When you have asymptotes. Yes. So the vertical one is, say that again, is this one. So it goes through the x. All right, questions so far? All right, so this is, if you look at this next picture here, the graph, this blue line is the parent graph, right? Do you see that? And we're going to compare what this graph right here, that I've almost written over here, this graph right here, oops, what that one looks like. So let's first make a t table here. All right, so -8. -4 divided by -8 is 1/2,
Okay.
right? 1/2. -4 divided by -4 is 1. -4 divided by 2, -2 is 2. -4 divided by -1 is 4. Okay, here's the trick question. -4 divided by 0?
Can't divide those two.
Very good. Undefined. Okay? And then it's going to go the other way. So it's going to be -4, -2, -1, and -1/2. So now let's graph this. All right, -8, or positive 1/2 is right here. -4, 1 is there. -2, 2 is there. And then -1, 4 is right there. So this is going to look something like this. And then on the other side, you get +8, -1, +4, -1, or sorry, 1/2 for that one. 1, +2, -2 is here. 1, -4 is here. And so this one looks like that. So the only difference between this one, the parent graph, and this one is that -4, right? So the negative on this tells us that it's reflected. And it's reflected over the x-axis. So the blue reflects up to the green. You see that? Okay. The 4 actually changes the shape, but very, very slightly. So we're not going to worry too much about that. It'll either dilate it or it'll compress it. But again, I'm not too worried about that. Just the idea that the negative will make that reflect into which quadrants? Quadrants 2 and 4. Okay. Questions so far? Okay, good? Okay. All right. So then, of course, we're going to get a little more complex, right? All right. So this is like the parent graph, but it's just got a little more added to it, right? Remember with translations, do you guys remember translations? We did that big worksheet and we kind of cut out the shapes and put it in the right place. What did the H tell us in that? What does the H tell us?
One of the points of the first set.
No. Huh? No, what? No. The H tells us the horizontal movement. When I say horizontal, I mean what? Left or right? Okay? And remember with this, it's always the opposite. It is. Okay? What does the K tell us? The K tells us the vertical movement. Good. The vertical movement. And when I say vertical, I mean what? Up and down. Good. And remember, with this, it is what it is. If it's positive, you're going to move up. If it's negative, you're going to move down. And then we just found out what A tells us. What does A tell us? If it's negative, it reflects. Good. So it tells us it reflects, or it tells us which quadrants it's going to be in, right? Okay, ready? Have you got that? Alrighty. We good? Okay. Whoopsie. Alright. So let's look at this first one here. What does this -3 tell us?
Horizontal movement.
Yep, and so we're going to move what?
3 to the left. Yeah.
3 to the right. Remember, that's the one that's the opposite.
Yeah.
It's going to be in the positive direction, right? So 3 to the right. What does the 4 tell us?
Yeah.
Up 4. Oops. Up 4. I guess I could have wrote the number there. And then the negative tells us
Reflects.
that it's reflecting. So, what you do is you start at the origin. You ready? We're starting at the origin. You start there. So start there. You start at the origin, and you move 3 to the right, 1, 2, 3, and then up 4. 1, 2, 3, 4. That's my new sort of origin. right? So that's where my new asymptotes are going to be. So here's the horizontal asymptote, and here is the vertical asymptote. If we were to name that vertical asymptote, what would it be named? X equals, huh? Where does it go through X, you guys? It goes through X at 3. Okay. Okay. Now, there's more than one reason. It's there because it translates, number one. But also, look, my X minus 3, that can never be what?
0.
X minus 3 can never be 0. So the asymptote is going to be where that is 3, because that graph can never quite get there. It's not allowed, right? And we found the vertical asymptote is at what? Y equals 4. Very good. Okay. Which quadrants are these going to be in?
1 in 4?
What's the parent one in?
1.
1 and 4, or 1 and 3, right? The parent, and it reflects.
Okay.
It's reflected, right? So it's going to be in 2 and 4, right? So my graph, sketching it, is going to look something like this. Okay? Might be a little deeper, but actually I think it is a little deeper than that, meaning that it goes a little closer.
It's in the 2 quadrant because of...
Because it reflects.
But it's...
Huh?
Wait, it's... Does everything start in the...
It always starts in 1 and 3 for these kinds of equations. It starts in 1 and 3. So when it reflects, so it starts here and here.
Yeah.
So when it reflects, it goes to 2 and 4. Because it was here and here, and then it reflects over that line.
Okay.
Like it did on the previous page, like this. Here, wait. Like it did here. See, it started here, but then it reflected because of the negative, and so it ends up in the second and fourth
Wait,
part.
are we referring to this one that goes down here? Is that where we get the first parent one from? Or
Yeah, the first parent one.
these?
This is the parent one right here. Right here.
Yeah.
So it starts in 1 and 3, and when it reflects, it goes to 2 and 4.
Okay.
That makes sense?
Yeah, makes sense.
Okay. All right. So how do we find the y-intercept when we're trying to find it with an equation? How do we find that? When the when we find the y-intercept, what is the x value?
0.
It's going to be 0. So we're going to let x be 0. Okay, when we let x equal 0, we'll see the equation here. Okay, it's going to be y equals negative 2 over 0 minus 3 plus 4. Or y equals negative 2 over negative 3 plus 4. Or 4 plus 2/3 is 4 and 2/3. So if I were to look for that on my graph, I would go to 1, 2, 3, 4, and 2/3. It's somewhere right around there. So my graph's, I'm actually pretty close there. So that's my y-intercept right there. Okay? So using the same idea, what's my x-intercept? I let y equal what? Let y equal 0. Okay, so we're going to let y equal 0 for this one. And when we let y equal 0, it's going to be 0 equals negative 2 x minus 3 plus 4. Now, this one's a little harder, right? To calculate, to find x now. The algebra is a little harder. So, let's do that. We're going to subtract 4. So you get negative 4 equals negative 2x minus 3. Okay, then you're going to multiply by x minus 3 on both sides. So you get negative 4x plus 12 equals negative 2. Subtract negative 12 from both sides. See, this cancels, right? So, and then I just distributed this. Okay. Then you subtract 12 from both sides. You get negative 4x equals negative 14. Divide by negative 4. You get x is 3 and 2/4, which is 1/2. So if we go back up to our graph to see if my x is somewhere around there, 3 1/2. You ready? So at 3 1/2, there it is right there. And that's pretty close too on my graph. How else could I find the x and y intercepts? I could graph it on a calculator, right? And look for where is the x0, where is the y0, and it'll give me those intercepts. Okay? Also, let's talk about domain and range. Remember, this is easy. Okay, domain. What's the domain?
X such that x cannot equal 0.
X such that x can't be equal to what?
Oh,
3.
3.
Okay.
Oh, that's
And then the range?
y such that y cannot equal
Y such that y can't be what?
1 2/3.
4.
Or 4.
Where's the asymptote?
4.
At 4.
Oh,
Good.
what? Okay, well.
Questions?
Can you go to the bottom for
This one?
Yeah.
The calculator one?
the x-intercept one?
Oh, yeah.
Just,
Okay, really quickly though, if you were to graph this on your calculator and you looked at the table at x equals 3, that's an asymptote, right? That's our asymptote. So when you look at the table, it'll come up as error. Okay, and that's an easy way to look for your vertical asymptotes. You can't find your horizontal asymptotes that way, but you can find them on your calculator looking for those errors. Okay, questions so far? Is anyone lost already? Okay, ready? Everybody ready? Okay, moving on. We're halfway done, you guys. All right, so you know they can't always be that simple, right? So when they're like that, where they have a fraction plus a number, you can use transformation. But when it's just a fraction, like this is a really,
God.
long way of looking at it. When it's like that, or if you want to go back to the front page, like this, when it's like this with nothing added to it, there's a different way to graph those. And here's the deal, you guys. If you do not go home and practice this tonight, then I can almost guarantee you will not be able to reproduce it next week. Okay? You've got to sort of memorize what's on this chart. And the only way really to memorize it is to actually do it on your own. And that's why I'm going to give you 30 minutes in class to do it today, maybe even more. Okay, so when you're graphing these numbers, sometimes you come up with what are called holes. Okay, holes are numbers that have been factored out. So let me give you an example of this. Let's see, x plus 2 times x plus 4 over x plus 2. Okay, before we ever do these, we're going to try to simplify them first. Can I simplify that one?
Yes.
Yeah, what can I do?
Cross out the x plus 2.
Cross out the x plus 2. So we get x plus 4. Now, if you were to graph x plus 4, what would it look like?
Just a linear line.
It would look like a linear equation, right? Now, is there anyone that's good on the calculator?
I'm still.
Huh? Okay, so somebody put in this original equation in here. So now, so if you were to put this original equation in, I'll just tell you what you get.
I'm not sure. I'm
do it
gonna
later.
try it.
If you were to put it in there, remember you gotta put double parentheses around the two that are parentheses. If you were to put this in, you would get a line. It would graph as a line. But when you went to the table, you would see at x equals -2, it would say error. The reason it says that is because the thing that you canceled out created a hole. They call those a hole. Now, we will not be testing you on holes at all. But I wanted you to see it because it doesn't go away when we cancel it. Okay, we're not going to test you to see if you understand what a hole is, but I wanted you to see what it is. Okay, and I'm going to show you one a little later that's like that. All right, but the rest of them, you're going to graph using this chart, okay? Most of these have already been simplified as far as they can today, so you don't need to worry too much about that. Just you need to worry about graphing them. All right, so some of this we've already done. For example, we've already done how to get the y-intercept. We do the y-intercept by setting y equal to 0 and solving for y. Or sorry, setting x equal to 0 and solving for y. That gives us the x-intercept. With these, it's a little different though. To get the x-intercept, you're going to set the numerator. What's the numerator, you guys? The top numbers, just the top equation, equal to 0, and that'll give you your x-intercepts. So you only need to worry about the top one to get the x-intercepts.
Wait, you
Makes it really
you set the numerator to 0?
Yeah,
Isn't that like
And
the
then
bottom
solve.
thing?
and that'll give you your x-intercepts. What?
Never mind.
Okay. Vertical asymptotes. You've done this too. This is just finding the domain. Okay? You set the denominator equal to 0 and then solve for x to get those vertical asymptotes. Okay, now the horizontal asymptotes are the toughest ones to get. And as we graph it, you're going to see none of this is too hard. So the horizontal asymptotes, you only look at the degree. What is the degree of a polynomial, you guys? It's the what? Good, the highest exponent, okay? So for example, I'll do case number 1 here. Let's say I have x plus 2 over x squared plus 7, let's say. Okay, can't be reduced. Okay, we're going to have to just graph that as is. So if we look at the degrees of this, what's the degree of the top one? The degree of the top one is 1. The degree of the bottom one is 2. So if this is the small, if it's small, the smaller one over the bigger one, like that, then our asymptote's going to be at y equals 0. No matter what it is, if our degree is smaller on the top than on the bottom, then my asymptote will always be 0. Okay? If I have x squared plus 4 over x, let's say 2x squared, plus 3, let's say. And where do these passes for? Where are you guys going? Oh, how did it go? It was okay, good. Grab the notes in the back, you guys. All right. Did you get the notes in the back? Okay. All right. So if the degree, so the degree over here, what's the degree on the top one?
2, or 1.
2, and what's the degree on the bottom one?
2.
Is 2. These are equal to each other, right? If that's true, then you look at the two coefficient of the first one over the coefficient of the second one. So for example, this one right here, the coefficient is 1, right? So my asymptote would be 1 over 2, or 1/2. So when they're equal, you're gonna do it like that. And then the last one is when, let's say you have something like x to the third plus 1 over x plus 7, where you have the degree of the top one is what? Is 3, right? And the degree of the bottom one is what? 1. So now it's the bigger one over the smaller one. When it's like that, there is no horizontal asymptote at all. So really, this is the one you got to memorize, okay? I learned it a little tiny bit different. So I'm going to show you this. If this is completely confusing to you, ignore it, okay? What I did was we always evened up the playing field. In other words, if I have an x squared down here, I got to create an x squared up here, like that. You see that? And so now I have 0 over 1. What's that equal to?
0.
0, right? So now you only deal with the coefficients, okay? You don't even have to worry about it as long as they're the same. So if you don't have one up here, you make one. So you get 0 over 1 is 0. So the asymptote is 0. Down here, to make it an even playing field, you add 0 x to the third, right? So it's going to be 1 over 0, and that's undefined. Do you see that? Can't have 1 over 0, so that's why there's no asymptote. So if that is confusing to you, that's fine. But if you just want to deal with the coefficients only, you can do it that way.
Does it cancel out the x squared at the bottom? Like on the first one?
You don't even worry about the x squared. You just need to even it up. So if there's an x cubed at the top, you got to create an x cubed at the bottom. So up here, these are the same, so you don't have to create anything. You just put the coefficients in front of each other. On this one, you had to create an x squared on the top, which had a 0 in front of it. So 0 over 1 is 0. Does that make sense?
Oh, because the answer anyways is going to be y equals 0.
Yeah.
Okay.
So this one is y equals 0, because 0 over 1 is 0. This one is going to be the fraction. This one is undefined, meaning there is no asymptote. Does that make sense? Okay, so you can do it either way. I don't care which way. You can either memorize the chart or you can use the little. This is the way I learned it. But everyone's telling me no, that's not right. So that's the way, when I was younger, that's the way I learned it. All right. So let's do this. These are kind of fun to draw, actually. Okay, does everyone have a calculator? You're going to need one, so get one. If you don't have a calculator, get one. Okay.
Or Indy, right?
Okay, ready? So I'm going to start with the vertical asymptote.
I don't even know what happened. There's a graphic on? Okay.
Okay. To get the vertical asymptote, remember, you just take the denominator and set it equal to 0. And then you solve for x. So you're going to add 9 to both sides. Get x squared equals 9. Take the square root. You get x is equal to plus or minus 3. See how I did that? Okay. So now let's draw this in. 1, 2, 3. So here's my, wait till you see these pictures. These are really cool. Okay. So there's my vertical asymptotes. Now let's find the horizontal asymptotes. Okay. Okay. Now, that horizontal asymptote, we're just worrying about the degrees, right? So what's the degree of the top one? The degree of the top one is 1. The degree of the bottom polynomial is 2. Okay. So this is small over big, right? The smaller number over a bigger number, right? So y is equal to 0. If you use the way that I just talked about, you would add a 0x squared. So it'd be 0 over 1 is 0. See that? You did it the way that I was just talking about. So y equals 0. So my horizontal asymptote is going to be right here.
Wait, what was the rule that you used for this?
So the other way of doing it, if you just want to deal with coefficients only, then since I have an x squared down here, I need an x squared up here. So I added a 0x squared. Okay, no matter what this one is on the bottom, I would add that. A 0, but with a 0, right? So it's adding no value. Then you look at the coefficients only. So 0 over 1 is 0. So that's my asymptote. Okay, so you can do it either way. Either memorize the chart or do it this way. All right. So now, let's do our sketch first. And the way that I would do it if I were you is I would pull out my calculator. Do I have my calculator out? No. Okay. And remember, when you're doing the calculator, it's really important that you put parentheses around your polynomials. Okay, so let's move this over here. See it? Okay. So, I'm going to clear this out. So it's really important that you do this parentheses, 4x, close the parenthesis, divided by parenthesis again,
This is big. This looks so weird.
x squared,
Like,
okay, minus 9. Now you guys, these are sketches, okay, so they're not going to be perfect.
when you look at it,
It's all good, okay? So when you graph this,
you look at it,
yours might actually have your lines in there.
Yeah,
I don't know how to get those actually on there. I'm going to have to look
unless
that
they're
up.
hieroglyphics.
Some of them, yeah, some of them have the asymptotes in there, some of them don't. Okay, so what this looks like is, look at it, goes through at 0, 0. That's our one pass through the, so it goes like this.
Oh, so we sketched.
You sketch this. Okay? And then you have two little branches, or arms, or whatever they call them, branches. Arms, 2 arms on our little thing. Remember, it's going to approach our vertical asymptote, but it's never going to quite get there. Okay, and it's going to approach the y asymptote, or the horizontal asymptote, but never quite get there. So those are kind of neat, right? Pictures. Fine, you might want to get some colored pencils for this.
Right? Oh, it's some.
Come on, go home, get your crayons out.
I haven't used crayons since
Okay.
yesterday.
All right. So the easy way to figure out what the x and y intercept is, you guys, how could I do that on my calculator if I wanted to find?
I do the thing.
Well, you could do the zeros, yes. You could do it that way. The other thing is you could just look at the table.
Oh, yeah.
Notice, what are these where it says error? What are these that say error?
Plus and minus 3.
They're the asymptotes. Good. So these are my vertical asymptotes. So could I find my vertical asymptotes on my calculator too? Yeah.
Yeah.
I could. If you're having trouble factoring it or something like that, you could go and find it on the calculator. Notice, 0, 0 is going to be my x-intercept and my y-intercept, right? Okay. So if I ask you to find that, the x-intercept is at 0, the y-intercept is at 0. Now, you could find this algebraically as well, right? To find the y-intercept, what do? we let x equal 0, okay? And to find the y-intercept, we let just the top equation equal 0 and solve for x. Okay? Questions? Any questions? Okay. Let's do another one. Don't you think these are a little fun?
Fun, I guess.
Come on.
They're fun to look at.
Okay, ready for this one? Vertical asymptote. How do I get that?
That's the denominator to you?
Yeah, you take the denominator, x squared minus 4, set it equal to 0. And add 4 to both sides, you get x squared equals positive 4. Take the square root. So you get x equals plus or minus 2. Now if you took this and graphed it, what would the plus and minus 2 be on my table?
Error.
Error, good. How do I find the horizontal?
At the top here.
Okay. Two ways to do this. You can either, well, in this case, we already have an x squared in both of them. So it's just going to be, if we just look at the coefficients, it's going to be 4 over 1, right? So y equals 4 over 1 because they're equal. 4, 4. So 1, 2, 3, 4. So my horizontal asymptote is going to be right there. All right, let's graph this one, because this one actually turns out even different than the first one. Oopsies.
Wait, there's only one of those?
We need. There can be more than one, but all of these are going to have one.
So you never do anything with the other?
We'll put in a number.
The 9.
No, we're doing nothing with that. All right. It does shape the graph, right? But we're going to graph it on the calculator. So y equals, again, don't forget your parentheses here. 4x squared minus 9, close the parentheses, divided by parentheses x squared minus 4. And close that parenthesis. Okay? And then here's your graph. This one's kind of crazy too.
Oh, yeah.
Yeah, kind of fun. This is fun, right? Okay. So it looks like this in the middle part. Nice parabola in the middle, right? And then it's got these here, like this. Okay? Now, if I wanted to find my... Huh?
Yeah.
You did?
Yeah.
Nice. Did you put parentheses around everything?
See, I just drew the sketch and
Let me see. And you didn't put parentheses. Oh, wait. Oh, yeah, you didn't.
Oh, I forgot to put the difference.
Yeah, you gotta do divided by in the middle. Okay, now, if I want to find my x and y intercept, one thing I can do is look at my table. And if you look here, you guys. This right here, where x is 0, what is that? That's my y-intercept. Now, the asymptote is where it's error, error, error. Remember? So this is where it crosses the y-axis at 2.25 or 2 1/4, right? And then we're going to find the x-intercepts where y is equal to 0. So let's look for that. Where is y equal? That's too big. Oh, y will never equal 0. So now we'd have to calculate that. It's just going to be a really icky number. Okay, how would you calculate that to find the y-intercept? The y-intercept you do by setting the top to 4x squared minus 9 equal to 0 and then solving for x to find the y-intercept. Okay? It's all on that chart if you forget. So it's 4x squared equals 9 divide by 4. So this is not a very nice number. X squared equals 9 over 4. It actually comes out kind of even though. So you get X equals plus or minus 3/2. You could do zeros on this though too, right? You could find the zeros on this graph, actually. You could do it that way too. So you could graph this and look for the zeros on this. So you could do second, trace, zeros, like that. And then go, I'm coming from the left. Oops. You would do stop there, and then one more time. And you get negative 1.5. Is that what I got? Yeah. Negative 1.5, and then you can do it on the other side and find it that way too. So you do this whole thing on your calculator, for the most part. Okay, last but not least, one more idea. We're going to skip 3 and 4. Actually, let's just look at 3 though, because I want to show you something. If I'm looking for my vertical asymptote on this, how do I do it? Yeah, so x squared plus 1 equals 0, right? And then I get x squared equals negative 1. What kind of number do I get here, you guys? Imaginary, good. So you get x equals 1i, plus or minus 1i. Okay. For asymptotes, they have to be real. So in this case, there are no vertical asymptotes. Okay, there will be a horizontal asymptote though. In this case, they're equal again, right? So it's just going to be y equals 8 over 1. Because our degree is 2 and 2. So my asymptote is 1, 2, 3, 4, 5, 6, 7, 8. Can be right here. Oops.
Wait, what, why 8?
Because my degrees are equal, so I just take the coefficients. 8 over 1. The horizontal. Okay. The y-intercept for this one. How do you find what the y-intercept again, you guys? You said x equal to 0. And then solve, do what? Okay, and then solve for y. So, I'm getting all mixed up. Okay, so y equals 0 plus 4 over 0 plus 1, or just 4. Okay, so 1, 2, 3, 4. Did anybody graph this already? Did anybody graph it? Okay, if you were to graph this, it would look something like this. It would look something like that. Okay, so these are all going to look different. You're going to have to graph it and just sketch it. Okay? You should be able to find the x and y intercepts on your calculator, and I encourage you to do that. Make this a good tool to be using. Okay, one last thing, and that's, we're going to do one of the bottom problems. And we're done. I promised you 30 minutes. I'm going to give you 30, actually more than 30 minutes. This class always goes faster than my other classes do. Because everybody's dead, I guess. Dead, tired. But, yeah, we took the SOL today. Was it hard or easy? Hard or easy?
It wasn't that bad.
Now I got on tape and everything.
Great file.
Okay, ready?
Talking about the SLSS last year.
Okay, ready, you guys? Okay, so this is one of those ones that creates a hole, and I just wanted to show you what it looks like if you were to graph it. Okay, so somebody, while I'm doing this, put this in your calculator for me. Okay, but you're going to factor this to x minus 3, x plus 2, all over x minus 3. Now, normally, you would assume that your asymptote would be at x equals 3, right? Because we set that equal to 0, right?
No, you factor it out, I mean, yeah.
But what happens is you factor out this x minus 3, right?
Linear.
So then you graph, you end up with x plus 2, right? Now, if you were to graph that, it would look like this, right? It would be at 1, 2 is where we begin, and then our slope is 1 over 1, so 1 over 1. Remember this, you guys? Wouldn't you love to go back to this?
Oh, what's the picture?
Back to the slope intercept form? You'd probably kill for that now, huh?
No.
Okay, so it looks like that when you graph it. Did anybody graph it? Is that what it looks like?
That's
Yes. Okay, now go to the table. Go to the table.
run to the table.
And then find x equals 3. What does it say?
Error.
Error. Okay? Because when you cancel this, it didn't go away. The restriction that it creates doesn't go away. So what it does create, though, is at x equals 3, here, it creates a hole. So that's the way you would graph that. You graph it like that with a little hole there. I would erase that, but I don't think it worked out very well. So look at that, there's a hole. So it was something like this if you were to graph it. So just so we look this, where's the hole over here, you guys? What are we going to cancel?
The 2.
X minus 2, so where's the hole?
At 2.
X equals 2. Good.
Okay.
We will not be testing you on that, but I want you to see it. It's important. Yeah. Yeah. Whatever you cancel out, that creates the hole. This one will be, but it'll still have the hole at x equals 2.
Right?
So wherever that x is equals 2 is, you would like put a little dot there on your graph. Okay, any questions? Okay, that's all I got for you.
Is this over here?